All right, guys. I'll get started here. Thanks for joining me here on Sunday night, getting ready for tomorrow's quiz too. First thing I wanted to go over is just some little things that I want you to be aware of that I know are going to be on the quiz. I know the whole thinking is around, geez, I got to know those multi-part circle questions and all the rules, but there are some smaller theorems that I do want you to be aware of going into tomorrow. Okay. First couple deal with inscribed angles because it's been a while since we did those. First theorem for inscribed angles is the following you should be aware of. Let me give you a drawing. Let's see that. You guys can see that. So if here's my center, I draw a couple chords in here. Call that point A, point B, point C, point D, and point E. All right, this first theorem that'll come up somewhere tomorrow on the quiz is why I know angle A and angle B are congruent to each other. Okay, how the heck do I know that angle A and angle B are congruent? Well, if you look at my diagram, they're both inscribed angles, aren't they? And the way you guys know how to find an inscribed angle is you take 1/2 of whatever the arc is. So to find angle A, I take a half of arc DC. To find angle B, I take a half of arc DC again. So you're taking half of the same arc. So A and B should be congruent because inscribed angles drawn to the same arc are congruent. Now, am I going to have you write that theorem down? Absolutely not. All right, there's no proof on there tomorrow. Inscribed angles drawn to the same arc are congruent. Okay, so you may see that theorem appear somewhere. Okay, maybe you'll need it to solve an algebra problem. I don't want to say too much more, but that'll come up somewhere. All right, the next theorem for inscribed angles that you want to be aware of, let me get a darker circle. Let's draw in a diameter. And I will draw okay, and that is, what do I know? Excuse me. What do I know about angle A? Well, it's in an inscribed angle. And do you see the arc that it's drawn to there? Arc BDC, which is 180. So if I take half of 180, angle A should be a right angle. But that's also a theorem too. All right. That's also a theorem that if you have an inscribed angle drawn to a diameter, it forms a right angle. Okay. Any inscribed angle that you draw to a diameter will also be a right angle. All right. That is different. That is different from this theorem. Oh, shoot, wrong one. Where's my go back button? Let's try that again. Let's get a circle there. All right, we should all know what this is right here. I'll just say this is my center right here. Draw my radius. Okay, this is a radius drawn to a point of tangency, which we know is perpendicular. But angle OAC is not inscribed. Okay, notice the difference between my two diagrams, please. This right here is an inscribed angle because the other two sides are chords, right? BA and AC are chords versus angle AOC, OAC. This is not an inscribed angle. And you're probably thinking, Mr. Carlino, why the heck are you going over this? Because it's going to come up. All right. One is an inscribed angle. The other is not. Yes, they're both right angles. I completely agree. But angle OAC is not an inscribed angle. To be an inscribed angle, the two sides of the angle have to be chords. All right. both sides of the angles have to be chords, and you guys can clearly see neither side of angle OAC in my second diagram are chords. Okay? So radius drawn to a point of tangency is perpendicular. While I'm on this topic, hey, let's not be an embarrassment tomorrow. If I give you something like r plus, I don't know, 10 squared, we are not going to write r squared plus 100 is equal to that. We're better than that. R plus 10, R plus 10. Okay? And then we'll FOIL it from there. Next thing I want to bring up before you answer any of your questions, just a reminder that this type of question will be on there tomorrow. All right. I'm going to have to make up numbers here. Let's say DC. Actually, I'll say DC is 24. AD is 9. BC is 4. What's the length of A to B? So what's the length of AB right there? Okay, this is a previous homework question. I warned you guys that it would be on the quiz, so here's just a reminder and a refresh. There's a couple ways to do it. The way I did in class was I took, well, first, using that theorem I just went over, which is, hey, radius drawn to a point of tangency is perpendicular. You should be able to put a right angle at D and a right angle at C. Now I'm going to take quadrilateral ABCD and make it into a rectangle and a right triangle. How do you want me to do that? I'm going to take the smaller radius, which is 4, and I am going to draw a line over that is parallel to DC over to DA. Boom, right there. So now what I've created is a rectangle on top and a right triangle on the bottom. Now you'll notice in this right triangle, I know no sides, do I? I know no sides. I don't know what I'm looking for the hypotenuse, AB, but I do not know the other two legs. But you guys should be able to pull out the other two legs now. The top figure is a rectangle, right? So if DC is 24, the opposite side has to be 24. If BC is 4, that radius BC is 4, opposite side has to be 4, because in a rectangle, opposite sides are congruent. And if radius DA is 9, I know a piece of it's 4, other piece has to be 5. So now we have the two legs. 5 squared plus 24 squared equals AB squared, or you can put C squared, X squared, I don't care. And then we're off to the races. Okay? So just something, is it going to be that exact problem where I give you those exact pieces? No, absolutely not. I could give you the distance from A to B, and maybe I need B to C. Maybe I need A to D. Okay, so just a heads up there, but you do want to try to break it up into a rectangle and a right triangle. What else did those were, I think, what I wanted to go over with you guys. The inscribed angle facts, difference between an inscribed and a not inscribed angle, and then this two-circle question here. So that's what I wanted to definitely brush up on with you. Is there anything you want to talk about right now? We can do any types of problems that you want. It's your call. Go ahead, speak up. You guys are here, spending the extra time, which I appreciate. So make sure you get enough out of it. Angles formed by tangents and secants. All right, so that's going to be outside of my circle. Go to a new page. Shapes, get another circle. Okay, so here's my tangent. Here's my secant. I'll call that angle P where they meet. I'll call that A, B, and C. Okay, so angle P is formed by a tangent and a secant. I don't really care that it's formed by a tangent and secant. You know what matters to me the most, guys? This angle's on the outside. On the outside, on the outside. So if an angle's on the outside, that automatically tells me I'm going to take 1/2 of two arcs being subtracted from each other. If the angle's on the outside, I'm going to subtract 2 arcs and take 1/2 of it. What arcs are you going to subtract? You got to subtract the ones that are in between the angle. BC, if you guys look at arc BC, that's not in between, so it's not even going to be involved in my calculation. I need the 2 arcs in between. The bigger one, AC, minus the smaller one, AB. That's how I'm going to find that angle on the outside formed by a tangent and a secant. Now, could I go 2 tangents? Yep. Could I go 2 secants? Yep. They're all going to be found the same way as long as that angle's on the outside of the circle. All right. What else you guys got for me?
This is a question about one of the problems that we had for homework
the other
night. And we were supposed to find GCE for question number 3. Actually, I think it was the work that we did in class. Sorry.
Nope. I have the packet up here. So you remember what page it was on, Sarah?
37.
Okay, let me get there. Yep, GCE. Yep, I have it right up here now. So if you look at GCE, and I always tell you guys, first question you want to ask is it inside or outside? And in this case, you can't answer that question if it's inside or outside. Because if you see CG is outside and CE is inside. So it's one of those between angles. So that you got to know how it's formed. If it's one of those between, like half of it's on the outside, half of it's on the inside, ask yourself, what are the 2 sides of the angle made up of? So first, let's go to CG. CG is a tangent, and then CE is a chord. So this angle is formed by a tangent and a chord, which is one of my special in-between angles. There we go. Let's get back to that. All right, so any angle formed by a tangent and a chord. The rule is it's the same as an inscribed angle. I take half its arc measure. All right, so if I go back to that problem, I take half its arc. The arc is 80, so I'm going to take half of 80, which is 40. Okay. Now I want you guys to notice, I don't know, can I blow this up? There we go. Look at that. Okay, now I want you to notice the difference between GCE, which is the one Sarah just asked. Now, hopefully we're in agreement that is formed by a tangent and a chord, so it's half its arc. Now, if I flip it on you and say, hey guys, can you guys find angle BEA for me? BEA. Now, again, do you see half of it's inside, BE, the other half is outside, EA. But now, how is this angle formed? A chord, which is BE, and now AE is part of a secant now. So there is no rule. If I asked you guys to find angle BEA, there's no rule for it. But I would still ask it, how to find BEA. Even though there's no rule for it, I would still ask you to find this tomorrow. So is there another way without knowing a rule to get to angle BEA? And the answer is you're darn right it is. What else could I find next to it that would lead me to BEA? I don't want to do all the talking here tonight.
FEC.
FEC, which is what type of angle, Sarah?
Supplementary. Oh, inscribed.
It's good. Yeah, it's inscribed. And then once you find that inscribed angle, it's supplementary to BEA. So you just subtract it from 180. Yeah. So I want you guys just to know before I take more questions, the difference between angle GCE, which has a rule, it's half its arc because it's a tangent in a chord, versus angle BEA, which is a chord and a secant, no rule. But usually you can just find the angle next to it because it's an inscribed angle. Okay? Other questions you guys have? I feel like we should just do a multi-part circle question together here while we're here, right? I figured that would be a good problem to go over. Now, I got 46 of these bad boys on Classroom right now. Anybody want to... Well, maybe... Yeah, there you are. Anybody want to step up and just give me their favorite number there between 1 and 46, and I'll just pick it and we'll roll.
32.
32, done. There it is, 32. I'm shoot, you know, there's 46 of these guys. I'm sure the two I put on the quiz are somewhere here. Let's see. Why am I drawing a blank on how to copy and paste this now? Anybody? I'm pressing Alt Shift and then that little button above the 6, but I'm not getting my copy paste button here. Anybody? A little help for the old guy here?
Try Control Shift.
Control Shift. There you go. Drawing a blank. That's why you guys are here to help me. I'll teach you the circles. You teach me the technology.
One job.
You're darn right it was. And I've probably done this a couple times already today, this copy paste and drawing a blank. All right, there we go. Let me just enlarge it a little bit. 32. All right, now let me go to work. Okay, AC is 140, so A to C 140, A to E 130. A to B, B to C is 6 to 4. So as you guys know, we'll put variables with them. So I'll call arc AB 6x and arc BC 4x. PD is a tangent. Make sure you read all through the directions. You don't want to skip anything because something may be getting bisected, and I think I got everything. All right, you guys know my advice. Find all the individual arcs that you can. All right, in this problem, I have 1, 2, 3, 4, 5 individual arcs. If you can find all 5 individual arcs, you're good to go. So I think the easiest way for me to start, everyone take a look, AOD. If it's circle O, O's the center, so AOD is a diameter. ED, 50 degrees. Ask me questions. Please chime in if you don't know where I'm getting at. Half a circle is 180. One part of it's 130, so the other part's 50. 6x plus 4x is equal to, what was AC? 140? So 10x equals 140. X equals 14. Take 14, plug it back in. Yeah, I'm going to pull this. Here we go. 14 times 6, 84. So this arc right here is 84. 14 times 4. Yeah, why not? It's late on a Sunday. 56. So this this arc is 56. All right, I got 4 now. Can I get a little help finding arc CD? That's the only individual arc I don't know yet. Can I get a little help on finding CD? Thanks. Appreciate it. How can I find the measure of arc CD before I even start any of the questions below?
Is AD equal to 180? So then can you do 56, 84, and then X for CD?
Yep. Okay. A, B, C, D. That arc right there, A, B, C, D, is 180 because it's a semicircle. So what I'm going to do is I'm going to take 180 minus the 84 minus 56. And that angle arc ends up being 40. Yay. There we go. 40 degrees for arc CD. All right. We should be good to go now, guys. We know all the arcs. And very conveniently, which is most of the cases in these multi-part circle questions, first at least 1 or 2 questions is probably something you already found. So arc ED, done, 50. Arc AB, done, 84. All right, now you guys got to take over with your rules. Angle BAD. Look where angle BAD is. Identify it. What type of angle is BAD? Anybody got it? Angle BAD is what type of angle in that circle?
Inscribed.
Inscribed. There you go. So I know my rules, and I'm going to take half its arc. All right, we got to be careful here, though, because at first glance, it looks like BAD just belongs to 56 degrees. It's more than that. It's more than that. We get the old highlighter here. Thicken that up. BAD belongs to more than just the 56-degree arc. It belongs to 56 and 40. So what I'm going to end up doing is not just taking a half of 56. I'm going to have to take a half of 96. 56 plus 40. Okay? Be careful there. Make sure you know the entire arc it belongs to. So that'll give me, let's see, a half of 96. Sure, why not? I'm just not in the mood to do these calculations. 48, there we go. Perfect. So 48 degrees. I'll plop that in my diagram. You never know, might need it. So there's 48. Done. Next up, APE. APE. Hey, I'm not even going to ask. APE. That sucker's on the outside of the circle. Outside, outside. So we are going to subtract 2 arcs, the 2 arcs in between. Let me get rid of my highlighted one here. There we go. The 2 arcs in between, angle APE, would be 130 for the bigger one, 56 for the smaller one. So I'm going to subtract those and take a half of it. So we're going to take half of 74, 37 degrees for angle P. There we go. Not too bad so far. Sometimes that last one's tricky. We'll see. How about angle EFD now? What type of angle we got there? EFD. Anybody? What do we call those? EFD. Anybody remember what type of angles we call EFD?
Is it a floater?
That's a floater. Good job, Ellie. Up, floater. Remember, if it's inside, it's got to be one of 3 types. It's got to be central, inscribed, or floater. And Ellie's correct. It's got a floater. So I'm going to take half. Now the rule for a floater is adding 2 arcs. Let me go back to my highlighter here real quick. So EFD belongs to an arc of 50 degrees. So I'm going to add that arc, 50, plus its vertical angles arc. So EFD, look at its vertical angle, and the arc that it belongs to is 56. So I'm going to take half of 50 and 56. EF. I just want to make sure I got everything good here. 50. That angle belongs to 56. We're good. So that's 106. I know this is 53. Just checking. Yep, 53 degrees. Okay.
Wait, I have a question.
Sure.
Sorry. So why isn't it AC, like the vertical one?
AFC.
Like, because when we add them, aren't they supposed to be like the opposite or whatever? So it'd be ED and AC. And so, like, I don't understand why it's BC, the arc that we're using for the second number to add.
Okay, so here's your EFD, which is this angle right here. So that would be its vertical angle. Oh, son of a gun. You're right, Sarah. That's my fault. Yep, another one job here. I knew something didn't seem right. Okay, let's try that again. Yes, its vertical angles arc would be arc ABC, which would be 84 and 56. So let's try that again. 84 and 56 would be 140. Yep, there we go. Half of 140, half of 50 plus 140. So that would be a half of 90, half of 190, which is 95 degrees. Yes, thank you. Yeah, something wasn't right there. Because there is no angle drawn to just 56. So, all right, thank you on that. Thank you. All right, so there is a typical multi-part circle question. Number 11 on worksheet 11. Well, you're going to have to get more specific there. Worksheet 11.
So one with 11.
Is that day 11 from our packet?
No, from the 3 worksheet you post.
Okay. All right. Let me get there. This one right here, it looks like Secants 11. Number 11 right here. Okay. Let me cut and paste it out. So this is one of the 3 worksheets I posted to Google Classroom on Inscribed Angles. Number 11. Okay, let me paste that. Okay. So which statement is not true here? Which statement is not true? So let me go through each of them right here and we'll see if they're true or not true. First one, triangle ABC is a right triangle. That is a true statement because angle B, angle ABC, is an inscribed angle drawn to a diameter. And that is what I showed you guys at the beginning of this review here. That's that theorem being applied right now. Okay, so that is going to be an inscribed angle drawn to a semicircle or a diameter, so that has to be a right angle, making ABC a right triangle. ABM is isosceles. Okay, that is correct because AM is a radius and BM is also a radius. And we know in a circle, all radii are congruent. So that makes ABM isosceles. So that is correct. Okay, let's get rid of this. So we know 1 and 2 are correct. We're looking for the incorrect one. Arc BC is equal to the measure of BMC. Yeah, because look, angle BMC is what we call a central angle. And a central angle is always equal to its arc measure. Central angle is always equal to its arc measure, which belongs to BC. So that is true. So now let's talk. Just by process of elimination, we know 4 is the correct answer, but why is 4 incorrect? half of angle ACB is equal to arc AB. Now, a lot of people think that's correct because you see, take a look, everybody. ACB is inscribed, so you're going to take half its arc, but that's not what's written here. It's not saying ACB is equal to half of AB. It's saying that AB is equal to half the angle. To make it correct, I would need the number 2 here instead of 1/2. Okay, because the rule is you take half the arc to find the inscribed angle. You don't take half the angle to find the arc. Okay, so that's why number 4 is incorrect, because the 1/2 should technically be over with the arc of AB. All right. Whew. Others you want to go over, specific examples, questions in general. Let me know, anybody. Trust me, it's going to be helpful that you guys hopped on here tonight, because I hate the weekend and giving the quiz on a Monday. It had to be that, though, in this case, but a lot of your fellow classmates, I'm sure, are going to be like, oh, yeah, we got a quiz. I'm ready for it. And they have no idea what's about to hit them tomorrow. Anything else you guys want to ask? I'll go over another type of question, same type of question. It's your call. I want to make sure I go over everything you need to, because you guys took the extra mile here to get on tonight on a Sunday night.
Can you go over number 30 on the multi-part circle problems?
Sure. Let me get them back up. Whew. I'm already intimidated by the diagram. All right, let's do this. Let's see what I'm given. The accompanying diagram. All right, we got diameters flying everywhere. EOC diameter, got it. Diameter AFOD, perfect. 180 degrees then for a half circle. Angle COD is 60 degrees. And angle AFB is 100. Ooh. Okay, here we go, guys. Let's see what we can answer here. Well, first thing, find as many arcs as you can, right? I don't care what the question looks like, find as many arcs. COD, that is a central angle, which is always equal to its arc measure. So that means arc CD has to be 60 degrees. Let's see here. What else can I find? AFB is 100. That's a floater. That is a floater angle. I don't know either of their arcs. Let's see. If you guys see something else too here, let me up. I can go ED is 120, right? Because remember, EOC was a diameter, and I already know part of it's 60, other parts got to add up to 180. So ED is 120, which now I can use that floater angle, right? If the floater angle was 100, it was found by taking half of arc ED, which is 120, plus arc AB. So now I can find arc AB. So I'll multiply both sides by 2. 120 plus AB. 80 is equal to arc AB. Boom. Let's see. What else can I find now, guys? If that's 80. Okay, here we go. AFOD is a diameter. So now I know ABCD is a 180 degree arc because it's a semicircle. So I can do 180 minus 80 minus 60. BC is going to be 40 to have all three add up to 180. And now I can find arc AE. I can find arc AE now because all arcs add up to 360. Let's see, what's it going to be? 120. I think this is going to be 60 again. If my math is correct, those add up to, let's see, that's going to be 100, 220, 220, and 140. Yep, that's 360. All right, perfect, perfect. I got all my arc measures now. All right, got all my, look for those diameters because remember, it cuts the circle up into 280 degree arcs. All right, help me out now, guys. Help me out. Arc DE. Already found it, didn't we? 120. All right, angle P. It's on the outside, outside, outside. So this should be half of two arcs being subtracted. Let's see. Everyone look at your diagram. What two arcs are between angle P? 120 and 60. So that should give me 30 degrees for angle P. I'll plug that in here, 30 degrees. Okay, let's keep rolling. ACE is next, the measure of angle ACE. Okay, what are we looking at here? A to C to E. That bad boy's inscribed, I believe. ACE is inscribed. So we're going to take half. Take a look. What arc belongs to angle ACE? 60. So we'll take half of 60. So that's a 30 degree arc or angle. ACE is 30. Whew. Next up, arc AB. Oh, found it already. It's 80 degrees. And our last part. What about angle ACD? ACD. All right, well, a couple ways we could look at angle ACD. It's inscribed, so I could take half its arc. Now, this is the third time we're going over this theorem tonight. ACD is not only inscribed, you see where it's being drawn to. A diameter, AD. So if you have an inscribed angle drawn to a diameter, we got ourselves a right angle here. And even if you didn't see that, it's okay if you didn't see that theorem being applied because it's still an inscribed angle, which I would take half its arc measure. And its arc measure is right here. AED, and that's 180. So you take half of 180, you're still getting to that 90. So even if you forget that theorem, big deal. Here's a bonus question for everybody too. Where is the other right angle in the diagram? Other than angle ACD we just found, anybody see the other right angle using another theorem that forms right angles? Where is there?
ADP.
What is it, Audrey?
ADP.
ADP, good. Yep, ADP. Radius drawn to a point of tangency is perpendicular. But again, this is not an inscribed angle right here. ADP, not inscribed, but it is still a right angle. Good. I love it. Good. Other questions, comments you want to talk to me about? Going? Feel confident? Yes, no, maybe? We know the rules. Central, inscribed, floater. Angle on the outside, like angle P. And then an angle formed by a tangent and a chord, half the arc. And then our inscribed angle theorems we talked about at the beginning of the session tonight. What's considered an inscribed versus not an inscribed angle. And then our little two-circle question here. where you got to find the distance between the centers using Pythagorean theorem. Okay, last call. All right. That was fun spending a quality Sunday night together. I probably will never do it again. Just joking, everybody. It was fun. Just joking. Be confident tomorrow. All right. If you have anything comes up between you now and your class tomorrow, feel free to email me as usual. Good luck tomorrow, guys. I'll see you guys tomorrow.
Thanks. Have a nice night.
You too, guys. Take care.